creating the class, the constructors, the methods, the data members. Objects, of course, are instances of a class. So I have a simple program, create object demo, which I also have online here. I'll jump to it. Actually, I'll just go there now. So create object demo. And what this does is doesn't have any, this is a class, but there's no data in this class. There's no constructor even, and it only has one method, and that is this method called main. You will learn later on in this term what this all means, but for now just consider magic. Your main, instead of having a main function like you do in a C++ program, one of your classes, or a class, if it wants to be able to run, needs to have a method that's declared as public static void main, and it takes capital S string square bracket args as its argument. So you just have to memorize that goes in that goes in a class if that class is meant to be a runnable class that you can run. So in this case, that's all it is. There's nothing else. So this has the main, and we're going to create a point object, a couple rectangles. We're going to print that out. We're going to swap the origin. We're going to print things out and do a few other things. Now, point and rectangle are also here. Point is very simple. It's got two public members, X and Y. Again, I don't recommend doing it this way, but I just left the code the way it is on the tutorial site. That's it for point. And rectangle is similar, is I have a width and a height, and I use point as an origin. Again, all public members. We've got my couple of constructors, and moves the origin point of my rectangle. Yeah.
So when you declare a primitive type, then do you have to initialize it, or is it automatically initialized to a value if you do not?
I think it's automatically initialized to 0.
Okay. Not null?
Not for primitives.
Okay.
And in this point origin, I think this is automatically initialized to null.
Right.
And then the constructor actually make it. Now, in this code again, I create a new point, a couple new rectangles. The first rectangle has an origin at origin 1, and then with the height of 100, 200. The second rectangle does not pass in an origin, so we'll see what that does. I print out the information for rect 1. Then I set rect 2's position to be origin 1, that same point. I print out rect 2's position, then I move that rectangle and print out again. I could run it, I can show you if you want, but it's pretty straightforward. Yeah.
What's the difference between printf and printline?
Printline does not have any format specifiers in it.
Oh, okay.
There's 3 of those. There's printline, which is going to return, printf, which actually has format, and print, which actually prints a line but doesn't return.
Right. You can do print without printline.
Does print format automatically end the line and start a new one? You would have to specify that in printf.
So printf works almost identical to the printf in C or C++. But for some reason, people don't use that. They use printline and print.
All that fun concatenation.
I think it's also because it is a lot faster. Printf has to do a lot of work to get the format specifiers figured out. All right. There wasn't much I was going to show there other than that's what we do. If I run it, that would look like that. Oh yeah, let's look at the constructors. Rectangle is interesting because notice has 4 constructors. So you can overload constructors just like other methods.
Just like C++.
Yes. So notice, well, yeah. Since constructors don't have a return type, so the issue of overloading on return type doesn't matter here. But I've got rectangle with no arcs, rectangle with a point, rectangle with a width and a height, and rectangle with all 3, point, width, and height. Okay, now, in this case, if I call rectangle with no arguments, then I just leave it as 0, 0, and I put the origin at 0, 0. If I call rectangle with a point, then I use that as my origin, and I leave these at 0, 0. In this case, I do something similar. I set my width and height to what got passed in, but I put my origin at 0, 0. Down here, I do everything. Yeah.
So how come with the second constructor where it just takes a point, it doesn't create a new point?
Because this is the one that got passed in.
So that's already been created as a new point?
Yes. Whoever called this constructor had to pass in a point object. So someone else would have made that point object.
And it would throw an error if that wasn't a new object?
Yeah, but you wouldn't even be able to call it without a new object. It might be null, the object reference might be null, which is fine, it would just set origin to null. So that would, yeah, I mean, other things would break down here because you're expecting it to be there, but, yeah.
Isn't that kind of dangerous?
Which,
The constructor that hits just a point and doesn't copy it?
no. You're thinking it's dangerous because what if the calling class deleted that point object, right? That it passed in?
Right, it doesn't actually delete that object.
Yeah, because it doesn't, there is no delete. And so what would happen is in the main that called this creates a point object, passes it in here, and now this guy ends up referring to that same object.
This is why I like Java.
Yeah.
Don't worry about
And
this.
so when I go back out to main, now I have one object, but I have 2 things referring to it, which you might not like, because that means if I change this, then it changes for both people. But I have 2 things pointing to it. Now in main, if I get rid of that reference or I reassign it to somewhere else, then it just reassigns somewhere else. But the one in here is still pointing to that object, so it still stays.
So with this constructor that we're talking about, could I write something similar to rectangle arc equals new rectangle, and then pass in new point with the x and y value?
Let me say that again. Would I do that in here?
Is it valid to pass in, I think it's called an anonymous object, where you just say new point?
Yeah.
as the